Okay, so we're going to look at this problem. This problem kind of clearly looks like it might be set up to be an alternating series problem. We've got a minus 1 to the power of k times a bk, and in this case, bk is equal to cosine of pi over 2 minus 1 over k. And so now, for this to be an alternating series, the first thing, even before we apply the alternating series test, we have to make sure that this is an alternating series, which means we have to make sure that the bk's are positive, or really the bk's are always negative. They have to be of one sign. So let's sketch the graph of cosine. So you want cosine of pi over 2. So we know that cosine of 0 is 1, and cosine of pi over 2 is equal to 0, and that's the first 0 that it gets to. So this is the graph. This is more or less the graph of cosine from 0 to pi over 2. Now we're looking at cosine of pi over 2 minus 1 over k. So if you look at cosine of pi over 2 minus 1 over k, well, there's a couple of things to keep in mind. 1 over k, the biggest it can be is going to be 1. We're starting the series here at 1. So the biggest that 1 over k can be is 1. Pi over 2 minus 1 is about 1/2. So in other words, bigger than 0. And this is, roughly going to correspond to cosine of pi over 2 minus 1. As k increases, 1 over k goes to 0, and so we're steadily getting closer and closer and closer to pi over 2. But at any rate, for any 1 over k, if k is between 1 and infinity, cosine of pi over 2 minus 1 over k is going to be positive, because we're always going to be on this part of the graph. Okay, so since 0 is less than or equal to pi over 2 minus 1 over k, and this is clearly less than or equal to pi over 2, the graph shows that the bk's are always non-negative. The bk's are always greater than 0. Okay, so we know this is an alternating series. Now we want to apply the alternating series test. In addition, if I look on the graph, if this is cosine of pi over 2 minus 1, as k goes to infinity, 1 over k goes to 0, and pi over 2 minus 1 over k is decreasing down to 0, increasing up to 0, and the graph is decreasing to 0. Okay, so in addition, as k goes to infinity, pi over 2 minus 1 over k increases to pi over 2, and the graph shows that cosine, as the argument to cosine increases to pi over 2, the cosine function decreases. So it's decreasing, which is one thing that you have to show in the alternating series test, and it decreases to 0, which is the other thing you have to show in the alternating series test. Well, can't talk and write at the same time. So it decreases to 0. So by the alternating series test, this converges. Okay, and that is it.